Welcome back. Let's practice determining if a number is a solution to an equation. All right, so here's our first example. We want to know, is 4 a solution of the equation? And our equation is x plus 4 equals 8. All right, and so if you want to check to see if a number is a solution to an equation, what you want to do is plug that number in for the variable in the equation. All right, assuming that you're only checking one number and there's only one variable, just like you see right here. So if we want to check to see if 4 is a solution of this equation, we want to plug 4 or substitute 4 in for x. And so if we do that here, replacing x with 4 gives us 4 plus 4 equals 8. And so simplifying, if you add 4 and 4, you do get 8, and so we have 8 is equal to 8. And so since we get a true statement, both sides of the equation are 8, and so we have 8 equals 8. That is a statement that is true. That means that 4 is a solution to this equation. All right, so our final answer here is that yes, 4 is a solution to the equation. Okay, let's take a look at another example. This time we want to know if -1 is a solution of this equation, and our equation is 2b minus 1 equals 3. And so we're going to plug in or substitute -1 in for the variable, which in this case is b, and then check to see if the resulting equation is true. If it's not, if we get a statement that's not true, then -1 would not be a solution. So let's see what happens here. And as these equations get more complicated, it might be helpful for you to draw a divider so that you can easily compare both sides of the equation. What I like to do is locate the equal sign and then draw a divider below it so that we can easily compare what's on either side of the equation to see if it's true or not true. So plugging in -1 for b, we'll have 2 times -1 minus 1, and then on the other side we still have 3. Then we want to simplify this side. 3 is already in its simplest form, but on the other side of the equation, we do want to simplify this. 2 times -1 is -2, so we have -2 minus 1, and then we still have 3 on the other side. But then -2 minus 1 is -3, and so we have -3 on one side and 3 on the other. So what we get here would be this statement, -3 is equal to 3, but that's not a true statement, is it? -3 is not equal to 3. So we would signify that by drawing a slash through the equal sign, creating a does not equal sign. So now this statement reads that -3 does not equal 3, right? -3 doesn't equal 3. So what we find here is that -1 is not a solution to this equation. Okay, in order to be a solution, both sides of the equation would have needed to be the same number. So our final answer here is that -1 is not a solution. Okay, let's move on to another example. This time we want to identify if 0 is a solution of this equation, and we have 4a plus 5 equals 3a plus 5. And so if we want to check to see if 0 is a solution of this equation, we need to plug in 0 or substitute it in for the variable of a in both places where you see that a. All right, in our previous examples, one side of the equation was just a constant, but now both sides of this equation are variable expressions. So we will have to simplify both sides before we can determine if the equation is true or not and if 0 is a solution to the equation. All right, so just like with the previous example, since there's going to be a little bit more work involved here, to help keep yourself organized, I recommend that you draw a divider below your equal sign, just as you're getting started working with equations. It's helpful for comparing both sides, so locate the equal sign and draw that divider. But now let's plug in 0, or substitute it in for a. So we'll have 4 times 0 plus 5, and then on the other side we have 3 times 0 plus 5. All right, now 4 times 0 is 0, and so is 3 times 0. Really anything times 0 is 0. So we have 0 plus 5, 0 plus 5, and anything plus 0 is itself. So we have 5 and 5. So now comparing both sides of the equation, we have the same number of 5. So what we get here is 5 equals 5, and that is true. That is a true statement. 5 is equal to 5. So what we find here is that yes, 0 is a solution to the equation. Okay? We plugged in 0 and found that both sides of the equation simplified to the same result, so it has to be a solution to that equation. Hey there, real quick, before we take a look at the next example, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's take a look at the next example. Next up, we want to determine if 2 is a solution to this equation. And you can start to see the equations are getting a little bit more complicated. This time we have x times the quantity x plus 1, and that is equal to x squared plus 5. All right, so once again, I recommend that you draw a divider below the equal sign to help you stay organized and compare the two values on either side of the equation. But if we plug in 2, in this case we're plugging it in for x is the variable in this equation, we'll have 2 times 2 plus 1, and then on the other side we have 2 squared plus 5. All right, now simplifying, remember to do what's in the parentheses first. 2 plus 1 is 3, so we have 2 times 3, and then on the other side 2 squared is 4, it's just 2 times 2, so we have 4 plus 5. Now, simplifying one more time, 2 times 3 is 6, so we get 6 on one side, and then on the other, 4 plus 5 is 9. So what we get here is a statement of 6 equals 9 for this equation, but that's not true, right? 6 is not equal to 9. So we'll write that 6 does not equal 9. That is not a true statement, or at least it wasn't before I drew the not equal sign, which means that 2 is not a solution of this equation. All right, so our final answer here is that 2 is not a solution. Okay, when we plugged in 2 into the equation for x, we got two different numbers on either side of the equation, so it can't be a solution. For our next example, we have is -2 a solution of the equation? And this time our equation is y cubed plus 2y squared minus 3y plus 1 equals 6. Okay, so our equation has a lot of terms on one side of the equation, but then just a constant on the other side. So really what we're going to be checking here is to see when we plug in -2 for each y and simplify this side, does it equal 6? All right, that's really what we're going to be checking here for this equation. And just to keep everything organized, I am going to draw a divider below the equal sign. But now let's plug in -2 for each of these y's and simplify. We'll have -2 cubed, or to the power of 3, and then plus 2 times -2 squared. Then you want to subtract 3 times -2 plus 1. And on the other side, we still have 6. Now simplifying, make sure to do all of the exponents first. -2 cubed is the same as multiplying -2 by itself 3 times. So you'd have -2 times -2 times -2. And we know that -2 times -2 is +4. And so you'd have +4 times -2, which is -8. All right, so -2 cubed is -8. And then we have plus 2 times -2 squared. And we're going to simplify the exponent first. -2 squared is +4. So we get 2 times 4. And then we are subtracting 3 times -2, which is -6. And then we have plus 1. And on the other side of the equation, we still have 6. Okay, now simplifying further, 2 times 4 is 8. So we have -8 plus 8, which is interesting because -8 and 8 would combine to be 0, right? So those two terms cancel out, or those two constants cancel out. And then we have negative 6. You can think of that as negative 1 times negative 6, which would be positive 6. So you have 6 plus 1, and on the other side we still have 6, which leads us to our final line here, where we'll have 6 plus 1, which is 7, and then 6 on the other side. So our result here for the equation is 7 equals 6, but that is not a true statement. 7 does not equal 6, which means that negative 2 is not a solution to this equation. All right, we plugged in negative 2 for all those y's and simplified, and we did not get 6, so the equation is not true. It's close, we had 7, but that's not 6, and so negative 2 is not a solution. All right, so my final answer here is negative 2 is not a solution. Okay, let's take a look at one more example for this video. All right, so for our last example, we want to check to see if the fraction of 1/3 is a solution of this equation. And our equation looks pretty complicated here. It involves two fractions that have variable expressions within them. So there's going to be a bit of work involved in simplifying both sides to see if 1/3 produces a true equation. And so let's get started here. I am going to draw a divider below the equal sign so that we can clearly compare both sides. But then plugging in 1/3 or substituting it in for each of these x's, there are 3 of them, here's what we get. We'll have 15 divided by 12 times 1/3 plus 1, and then 3 times 1/3 plus 8 divided by 5 minus 6 times 1/3. All right, now simplifying. In the denominator here, or the bottom of the fraction, we have 12 times 1/3, which would be the same as 12 divided by 3, right? You can multiply 12 into the numerator of that fraction. That's how you multiply a whole number in a fraction. 12 times 1 is 12, so you'd have 12 divided by 3, which we know is 4. So we have 15 divided by 4 plus 1, and then over here, 3 times 1/3 is 1, because 3 times 1 is 3, then you have 3 divided by 3, which is 1. So we have 1 plus 8 divided by 5 minus 6 times 1/3. Multiply 6 by the fraction, you have 6 times 1 in the numerator, and then 6 divided by 3 is 2. So we have 5 minus 2. All right, now simplifying further, 4 plus 1 is 5, and so you have 15 divided by 5, which is 3. But I'll write it like this. We have 15 divided by 5, which gives us 3. And then on the other side of the equation, 1 plus 8 is 9, and we're dividing by 5 minus 2, which is 3. So you have 9 divided by 3, which is also 3. And so if you look at that, the result here of the equation is 3 is equal to 3, which is true. That is a true statement. 3 does equal 3, which means that 1/3 is in fact a solution of this equation. When you plug in 1/3 for each of those variables of x and simplify both sides of the equation, you get the same result. So our final answer here is yes, 1/3 is a solution. Okay? And with that, that is it for this example, and this was also the last example for this video. But if you do want to get more practice, I have another available on my membership site. So if that's something that interests you, feel free to look into becoming a member. You can find all the details on my website at jkmathematics.com/plus. I'll also have a link for that in the description of this video. If you have any questions, please let me know in the comments. But if you don't have any questions, this is all I had for now, so I will see you next time.